Hello dear friends, welcome to the lecture of differential calculus. In this lecture we shall solve some multiple choice questions on the topics successive differentiation, partial derivatives, mean value theorem and some part of vector calculus which include differential operators. So I have written here few questions. I will suggest you to write your answers on a paper and then verify the answers. Take a screenshot of it. The first question is, for all x belongs to R, hyperbolic sine of negative x is equal to which of these? Hyperbolic sine x, negative of hyperbolic sine x, hyperbolic cos x, negative of hyperbolic cos x. And we know that as like circular functions, hyperbolic sine of negative x is equal to negative hyperbolic sine, because what is the definition of hyperbolic sine? Hyperbolic sine is e power x minus e power minus x divided by 2. This is hyperbolic sine x, and hyperbolic cos is there is plus sign for in between these two exponential functions. And if you replace x by minus x, hyperbolic sine negative x, so that will be e power negative x minus e power negative of negative x, that is e power x divided by 2. And you see here, if you take the minus sign common, then this will be e power x will be positive term and this will become negative term, and therefore this is negative of hyperbolic sine x, and thus the correct alternative is negative of hyperbolic sine x. Second question, if y is equal to cos of ax plus b, then nth derivative of y is equal to nth derivative of y with respect to x is equal to which one? So actually this is the result we have obtained. If y is equal to cos of ax plus b, then its nth derivative is given by a power n cos of ax plus b plus n pi by 2, and therefore the correct alternative is the first one, a power n cos of ax plus b plus n pi by 2. Next is, if z is equal to log of x square plus y square, then what is the second derivative of partial derivative of z with respect to x? Second partial derivative of z with respect to x, that is asked. And for this purpose we see we can find the first derivative. If it is z, then what will be dou z by dou x? Z is log of x square plus y square, then dou z by dou x will be log of x, the derivative is 1 upon x, and we are differentiating partially with respect to x, we have to treat y as constant. So first it will be 1 over or 1 upon x square plus y square into partial derivative of x square plus y square by chain rule, and the partial derivative of x square plus y square, derivative of x square with respect to x, that is 2x, and the derivative of y square will be 0, because when we differentiate partially with respect to x, we treat y as constant. So this much is the first derivative, or which will be 2x divided by x square plus y square. And now the second derivative to be obtained using the quotient rule. So dou 2z by dou x square is equal to, and if you use the quotient rule, then it is square of the denominator at the denominator, and then denominator, that is x square plus y square into derivative of numerator with respect to x, that is 2, derivative of 2x is 2, we are using quotient rule of derivative, minus the numerator, that is 2x, into derivative of the denominator, that is again 2x, so 2x into 2x, and thus it becomes, now you see, 2x square minus 4x square, that is minus 2x square, and plus 2y square divided by the denominator is x square plus y square whole square. This is dou 2z by dou x square, and we see the correct alternative here is B. Only we have used the differentiation 2 times to get the partial derivative, treating y as constant. Next is curl of r bar, where r bar is position vector of any point x, y, z. Now if r bar is position vector of any point z, then we can write r bar as So this is over. So we have r bar is equal to position vector of a point x, y, z, means r is ix or xi plus yj plus zk. And we know the expression for curl of a vector is given by the determinant. First row is ijk, second row is the partial derivatives with respect to x, y and z, and third row is the component of the vector. So that are x, y, z, ijk components of r bar. So this is the expression of curl r. And in general, if it is f bar, then f1i plus f2j plus f3k, then the last row will be f1, f2, f3. So by definition. And then what is the expansion of this? I into dou z by dou y. So that is 0, dou y by dou z, that is 0. Because when we differentiate this z partially with respect to y, we treat it as constant. So partial derivative of different variable will be 0. Because we are treating other variables as constant. So dou z by dou y is 0, similarly dou y by dou z is 0. So the first term is 0, next is minus j, and then dou z by dou x is also 0, dou x by dou z is also 0. Then k, dou y by dou x is 0, dou x by dou y is 0. So every term is 0, so that is 0 vector. And curl r bar, the correct answer is 0. Actually it is 0 vector. And next is, if phi is constant, then what is gradient of phi? Gradient of phi we know is defined by grad phi is equal to I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. So this is the expression for gradient of phi, and here phi is constant. So because phi is constant, this dou phi by dou x will be 0. Partial derivative of phi with respect to x is 0. That of with respect to y is also 0. Partial derivative of phi with respect to z will be also 0. And therefore this is again a 0 vector. So the correct alternative is the first one. And next is, if y is equal to sine 3x plus 5, then what is y5? So we have two types of results. That's why I have kept this result. If y is equal to sine ax plus b, then yn, nth derivative. Yn means nth derivative of y with respect to x. This is the notation. So that is again of the same form. If it is cos ax plus b, then nth derivative is a power n cos of ax plus b plus n pi by 2. And if it is sine, the result is exactly similar, a power n sine of ax plus b plus n pi by 2. So this is nth derivative. And here the function given is, see, the function given is y is equal to sine 3x plus 5, and therefore if y is sine 3x plus 5, what is the value of a? A is 3 and v is 5, and we want y5. So y5 will be a power n, that is n is 5 here, and a is 3, so 3 power 5 into sine of 3x plus 5 plus n is 5 plus 5 pi by 2. And so this will be the this is the correct answer, and therefore the alternative correct is, you can see, is C is correct. So these two formulae we have to remember. For y is equal to cos of ax plus 5, yn is this one, and similarly for y is equal to sine of ax plus b, yn is this expression. Next one is the value of nth derivative of ax plus b power n. Nth derivative of ax plus b power n. Actually we have the formula for nth derivative of see, this is 7th, nth derivative of ax plus b power m is m factorial a power n divided by m minus n factorial into, or the numerator can be written as ax plus b power m minus n. So, this is the general formula. All these standard formulae we have derived earlier, and we have to remember it. And here these two are equal, m is equal to n, and therefore nth derivative of ax plus b power n is asked. So, these two are equal, and therefore if m is equal to n, then we will have this as n factorial divided by m minus n, that is 0 factorial a power n, and ax plus b n minus n. So, this is this will be 1, ax plus b power 0 is 1, and therefore, and 0 factorial is also 1, and therefore the answer will be n factorial into a power n, and thus this b is the correct alternative. Next is if z is equal to x plus y divided by root x plus root y, z is given, and then the x, the value of x dou z by dou x plus y dou z by dou y is equal to which one? Here z is a homogeneous function, and we can use the Euler's theorem. Z is homogeneous function of which degree that we can observe. It is a power of x and y at numerator is 1 same, and at the denominator the power of x and y is half. So, degree of z will be 1 minus half. The numerator has power 1 and denominator has power half. Numerator is actually homogeneous of first power, denominator is homogeneous of second half power, and therefore the power of whole expression will be the subtraction of these two powers, and that is half, and this is n, we shall suppose. Then by Euler's theorem is x dou z by dou x partial derivative of z with respect to x plus y partial derivative of z with respect to y is equal to n times z. And what is n here? N is half, degree of z. Degree if it is homogeneous, n is the degree of z, and that is half into z. So, this is the correct alternative for this half z. Next one, here it is asked, the gradient is asked, and we have defined these differential operators we have defined in the chapter of vector calculus. That is the operator del. Also we have studied directional derivatives, then the operator del, then gradient phi, divergence of f and curl of f we have defined, and their properties. So, gradient of r is this vector. So, what is the gradient of r? Gradient of r is I dou r by dou x plus j dou r by dou y plus, so this is r, and then next is j k dou r by dou y. So, gradient of r is not r bar, gradient of r is r. So, this is not correct, because gradient is defined for scalar functions. So, what we have to consider is if r is xi plus yj plus zk, then what is r? R is magnitude of r bar, this vector, and magnitude is x square plus root of x square plus y square plus z square. Magnitude of this vector is this one, and we want to find gradient of this, and therefore this will be written as gradient of r is equal to, and we write this in sigma notation, summation I dou r by dou x, or that will mean I dou r by dou x plus j dou r by dou y plus k dou r by dou z. But we will obtain this one term only, and this function is symmetric. Similarly, the partial derivative of it with respect to y and z can be written similarly. So, this is summation I, what is the dou r by dou x, partial derivative of this. You see, it is a derivative of root x is 1 over 2 root x, and therefore it is 1 upon 2 root of x square plus y square plus z square or into derivative of inner function with respect to x, partial derivative with respect to x, that is 2x, and partial derivatives of y square z plus z square will be 0. So it is 1 into 2x. These two can be cancelled, and what remains is x divided by root of this. So therefore this is summation I x divided by root of this quantity is again r. So x upon r. And what is the meaning of this? This summation means this will be Ix plus jy plus kz divided by r. Summation is over I and x. I changes to j and j changes to k, or summation of Ix means Ix plus jy plus kz. And again, what is this? This is r bar. This vector is r bar. So this is equal to r bar divided by r, and this is the unit vector along r bar. A vector divided by its magnitude gives unit vector along the same vector, and that unit vector is denoted by r cap, unit vector along r bar. And thus the correct alternative for this one is r cap. R cap is the unit vector. Next is for all x belongs to R, e power x. That depends on Maclaurin's series expansion. E power x, and we have studied Taylor's theorem, then Maclaurin's theorem, and expansion of function using Maclaurin's theorem we have studied, and we have obtained the standard functions expansion, that is e power x, then e power x, then sin sin x and cos x. So this we have to remember. E power x, the expansion is 1 plus x, actually x power 1 divided by 1 factorial, x square divided by 2 factorial, x cube divided by 3 factorial, and so on. For sin, it is x minus x cube divided by 3 factorial, odd power terms, and alternate sign is plus minus, plus x power 5 divided by 5 factorial minus, and so on. For cos, it is 1 plus x square divided by 2 factorial minus 1 minus, it is 1 minus x square divided by 2 factorial plus x power 4 divided by 4 factorial, and so on. Yes, minus, etc. So these are the expansion standard for standard functions, and therefore here the correct alternative is C, this one, D. D is the correct alternative for. Next is gradient of r dot a, r bar, gradient of r bar dot a bar. Here again we have to select the function r bar, the vector r bar, as the earlier, that is let for 11th r is equal to xi plus yj plus zk, and a bar is, we will write this as having components, a bar having components a1, a2, a3, and a1i plus a2j plus a3k. Then what is r bar dot a bar? Dot product of these two vectors is I dot I is 1, j dot j is 1, k dot k is 1, and I dot j etc. will be 0, or that will be x a1, I component into I component plus y a2 plus z a3 is r bar dot a bar. Then gradient of this, so gradient of r bar dot a bar is equal to I partial derivative of this with respect to x, and that is partial derivative of this with respect to x is only a1, that of y with respect to y and z, or y a2 and z a3. Here a2 a3 are constants, and when we differentiate partially, or it can be written as summation I dou r bar dot a bar by dou x, sigma of this type, and that is summation I. What is partial derivative of the whole expression with respect to x? Partial derivative of first term with respect to x is a1, and we should not write dot, but we should write a1, and partial derivative of this with respect to x is 0, and this with respect to x is also 0, so only this much. And sigma I A1 means I A1 plus j A2 plus k A3. Components of this vector are A1, A2, A3, and which is again the vector A bar. So this is the correct alternative for 11th question. Then value of divergence of R bar is, again you see R bar is this vector, and what is the divergence? So divergence of the vector R bar is by this sigma notation I dou by dou x dot R bar. And what is this derivative, partial derivative of R with respect to x? Again this will be summation I dou by dou x of R bar, or dou R bar by dou x, or that is summation I dot, what is dou R bar by dou x? That is 1. See, partial derivative of this with respect to x is 1 into I, and therefore it is 1 into I. This will be 0 and this partial derivative will be 0 with respect to x. So that is 1 into I means I dot I, and I dot I, this will be summation I dot I is summation I dot I, or full expression will be sum over such terms, that is I dot I plus j dot j plus k dot k, and each is 1. So it is 1 plus 1 plus 1, and that is 3. So thus divergence of R bar is 3, and this is the correct alternative for the last question. These are the next questions. Again I would like to suggest you take a screenshot, write your answers and then verify. The 13th question is the value of C, the value C of Rolle's theorem for the function f of x is equal to sin x in the interval 0 to pi is which one? And we know the Rolle's theorem, if a function f is continuous in the closed interval a b, second condition is it is differentiable in the open interval a b, then there exists at least one value c such that f dash of c is equal to 0. C belongs to interval a b. Here the interval a b is 0 to pi, means a is 0 and pi b is pi. And what is f dash of c? See, the derivative of f of x is cos x, derivative of sin x is cos x. So that means here cos c is equal to 0. F dash of c means cos c is equal to 0. And cos c is equal to 0, this implies what is the value of c? C is equal to pi by 2 in this interval 0 to pi. And therefore the correct alternative is pi by 2. The next one is if y is equal to hyperbolic sec x. This is not circular function, it is by notation, this is a hyperbolic function, h is written here, hyperbolic sec x. Then what is the derivative of hyperbolic sec x? Hyperbolic sec x can be written as 1 upon cos, hyperbolic cos, and then its derivative can be written as derivative of hyperbolic sec, that is d by dx of 1 upon hyperbolic cos, and by the quotient rule we can write the derivative as the denominator is square of hyperbolic cos and numerator is hyperbolic cos into derivative of numerator, that is 1 which is 0, derivative of 1 is 0, we are using quotient rule, minus 1 into derivative of hyperbolic cos, and that is hyperbolic sine. So therefore this is negative hyperbolic cos upon hyperbolic cos square x, and that can be written as negative sine hyperbolic divided by hyperbolic cos is tan hyperbolic x into 1 upon cos, that is sec hyperbolic x. 1 upon cos is sec, hyperbolic sec it is, and thus this will be the correct alternative. We have used the quotient rule, and that is the second alternative B. Next one, if y is log of ax plus b, then yn. This is the direct formula. Derivative of nth derivative of log of ax plus b is given by, we have obtained these formulae, standard formulae, and you may refer what is y1. y1 will be here 1 upon ax plus b, a into 1 upon ax plus b, or that can be written as a into ax plus b power minus 1, etc. And the formula for nth derivative is this one, minus 1 to the power n minus 1 factorial a power n divided by ax plus b power n. That is the correct alternative. Next one is divergence of f bar plus g bar is equal to, and this is simple. For plus or minus addition or subtraction, the divergence gradient curl will be according to the addition or formula for or the derivative of sum or difference, and this will divergence of f plus divergence of g, and that is the last alternative, divergence of f plus divergence of g. The gradient of scalar point function is, scalar point function means a constant function, and we know the gradient is defined like this, gradient phi is I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z, and which is certainly a vector function, vector point function, because if a gradient at a point is asked, then we will get gradient at that point as vector function at that point, and therefore it is a vector point function. So this is the correct alternative for this question. Next one is, if y is equal to log of hyperbolic cos x, then what is dy by dx? So derivative of hyperbolic cos function can be obtained using the usual rules and formula of differentiation. If y is log of hyperbolic log of cos log hyperbolic cos x, then dy by dx is 1 over 1 upon hyperbolic cos x into derivative of hyperbolic cos x, that is hyperbolic sin x. Both the derivatives are positive. Derivative of hyperbolic cos is hyperbolic sin, derivative of hyperbolic sin is hyperbolic cos, and this is sin upon cos, which is hyperbolic tan x, and thus the correct alternative is this one. For gradient of phi into psi, the usual product rule follows. We have proved these properties of divergence, curl, and gradient of product of functions, and that is phi gradient of phi psi is equal to phi gradient psi product rule plus first function as it is gradient of second psi plus now psi as it is gradient of phi, and thus this is the expression for gradient of phi into psi, and the correct alternative we see is this one, phi gradient psi plus psi gradient phi. For x belongs to R, what is this expression? Hyperbolic cos square x plus hyperbolic sin square x. So this expression is not 1. That for circular function, cos square x plus sin square x is 1. For hyperbolic function, hyperbolic cos square minus hyperbolic sin square is 1. And here it is the formula for hyperbolic cos 2x. We can verify this using the formula for hyperbolic cos. So that means hyperbolic cos is e power x plus e power minus x divided by 2 whole square plus this expression is hyperbolic sin square means e power x minus e power minus x divided by 2 whole square, and this can be seen as, if we expand this, the middle term of this and the middle term of this will cancel, positive and negative, and what remains is e power 2x, that is twice it is. So not e power 2x but e power yes, it is e power x whole square will be e power 2x, and this is e power negative 2x, and these terms are double. So that is 2 will be there, twice terms, and divided by 2 square will be 4, or therefore this is e power 2x. You should verify this, the calculations, and plus e power negative 2x divided by 2 by 4, and which is hyperbolic cos 2x, and thus this is the correct alternative. The next one is z is x power n f of y by x. So this is a homogeneous function of degree n, and that is Euler theorem we have seen. By Euler's theorem, that quantity x dou z by dou x plus y dou z by dou y is n times z. So direct theorem result is nz. And if f of x is equal to x square in the interval 1 to 2, then the value of c in Lagrange mean value theorem. Lagrange mean value theorem is, so if the function is continuous in the closed interval 1 comma 2 and differentiable in the open interval 1 comma 2, then there exists at least one value c such that f dash of c is equal to f b minus f of a divided by b minus a. And what is f dash of c? F dash of x is 2x, so f dash of c will be 2c is equal to, now what is f of b? B is 2, so 2 square is 4 minus 1 square is 1 divided by 2 minus 1. A is 1, b is 2, and that is 2c is equal to 4 minus 1 is 3, and c is equal to 3 by 2, and that belongs to the interval 1. So therefore the correct alternative is this one. And the next is, for every x belongs to C, cos x is, so that we have seen by Maclaurin's theorem. The expression for cos is having the first term as 1, the next is even terms x square divided by 2 factorial, alternate terms are positive, cos x is equal to, and plus x power 4 divided by 4 factorial minus x power 6 divided by 6 factorial plus x power 8 divided by 8 fact. This is the expression for cosine of x, and therefore the correct alternative we may see is only 3 terms are written here, and therefore this is the correct alternative. So in this way we can solve multiple choice questions on differential equations. Differential calculus we have solved, few questions we have solved. You may practice similar type of questions. Thank you for watching the lecture.